For the last section of 1.2 from your book, we're going to look at financial models which can be written in a linear format. First, let's look at a cost function. So when the cost to produce a part can be written as a linear function, then we can write it in the form of C of x equals mx plus b. Now m, in this case, is called the marginal cost, or it's the additional cost per item for production. B is called the fixed cost. This is the amount required just to get ready for production, even without producing any parts. In the first example, suppose that we look at a cell phone company which charges $15 per month plus $0.01 or 1 cent per call or text made for a customer. Then the cost of the cell phone for a customer can be written as the linear function C of x is 0.01x plus 15. So the marginal cost is the 1 cent per call or text during the month, and the fixed cost is the $15 per month charge to have access to making calls and text using this particular company. In the second example, suppose that we look at the cost of milk at Kroger. And for simplicity, let's just say that it's $2.50 per gallon purchased at Kroger. What would a cost function for a customer be for the amount spent on milk at Kroger in terms of number of gallons purchased? And we're going to ignore tax. Now, it doesn't cost anything to walk into the store, so there really is no fixed cost, or we would say the fixed cost is zero. But each gallon of milk purchased is $2.50. So we would write that marginal cost and put it into our equation as C of x is 2.50x. So then C of x is going to be in dollars, x is the number of gallons of milk purchased, and you can easily calculate how much is spent based on number of gallons of milk purchased. Another way to consider revenue, cost, and profit is to look at a break-even analysis. Now, revenue from selling some number of X units of an item is simply the product of the price per unit times the number of units sold. So we could write R of X is just the product PX. And then the profit function is going to be basically revenue minus cost. So P of X is R of X minus C of X. If cost exceeds revenue, you would have a loss on that product. If revenue exceeds cost, then you have a profit. The point where it changes from loss to profit is called the break-even point. It's where revenue and cost are equal to each other. That identifies sort of the number of units you need to sell so the company breaks even or does not lose money but starts to make money. Consider a farm which examined the process of getting milk to local stores. Suppose that the cost was 1.2x plus 500 in dollars, where x is the number of gallons of milk produced. Revenue was 1.5x, so basically they charged $1.50 per gallon of milk they sold to the local store. What is the break-even point? In other words, how many gallons of milk need to be sold for the farm to break even? Well, there's two ways to sort of look at this. We can look at it as the profit being equal to zero. So we write the profit function as the difference in terms of revenue minus cost. So we would write 1.5x, which was the revenue, minus the function 1.2x plus 500. Now you have to distribute the negatives, so be very careful here. So then profit is going to be 1.5x minus 1.2x minus 500, or simplifying, we get 3/10x minus 500. And then we would solve that for P of x equal to 0. So the profit would be 0, that would be your break-even point. The second method is to set revenue and cost equal. So revenue equals cost. In other words, 1.5x equals 1.2x plus 500 at what value of x? So then you would subtract 1.2x from both sides, and you'd get the same equation we had earlier, where 0.3x equals 500. Okay, and we want to solve that for x. So divide through by 3/10. So 500 over 0.3 will produce 1,666 2/3. So to break even, the farm must sell 1,666 2/3 gallons of milk, or about 1,667. Now another question we can ask deals with profit. So what would the profit be if the farm sold 2,000 gallons of milk? Well, what we can do is go back to our profit function, either in the simplified form or the revenue minus cost form, either way, and plug in x equal to 2,000. So P of 2,000 would be 0.3 times 2,000, which is 600, minus 500, or 100 would be your answer. So if the farm sells 2,000 gallons of milk, the profit will be $100. Now, even though I don't have an example here, I could ask a question where I say, using the profit function or using revenue and cost functions, whatever, how many units, in this case gallons of milk, would need to be sold if you want the profit to be $150 or some given number. So then what you would have is basically the profit, you know that value, and you would be solving for x in that case. But that's something that we've looked at in linear models before, and you should be able to do. So those are some examples of financial models related to revenue and cost and such.